Yes, so students, now for understanding of that exact capacitor, capacitance of a capacitor, see some well-known example. Here, students, I am taking one conducting sphere of radius r. Here, one conducting sphere of radius r I have taken, and charge capital Q given to this. Charge given to this conducting sphere. We all know from our electrostatics chapter, after giving this charge to conducting sphere, charge will come to the surface and resides on the surface. So from the surface, electric field moves from high potential to low potential, like this. Electric field is moving from the surface of our conducting sphere to infinity, means very far away. So wherever electric field is there, yes, their energy can be stored. So now here electric field starts from surface to infinity. That means here electric field exists from surface to infinity. That is high potential to low potential. That potential difference delta V, potential on the surface of conducting sphere minus potential at infinity. This is the potential difference between the points. In between these 2 points, electric field exists. This is nothing but potential on the surface, because potential at infinity is a 0. What is potential on the surface? Capital Q divided by 4 pi epsilon naught capital R. This is the potential difference between the surface of a conducting sphere to infinity, means very far away point. Students, here potential difference is proportional to the charge given to the sphere, means more charge given, more potential difference. More potential difference, more charge now to be given. So that means here, students, charge Q is proportional to delta V. Whatever may be the charge stored here, this charge is proportional to potential difference. More potential difference, yes, we can now charge. That means we can store more and more charge. So that means Q is proportional to potential difference. Potential difference from where to where you need to consider? Yes, from where to where electric field existed. Yes, that 2 points, between those 2 points, you should consider potential difference. So that is delta. So charge stored is proportional to potential difference. That proportionality constant is nothing but C. Q equal to C into delta. This proportionality constant is nothing but a capacitance of our conductor. Means here indirectly it is a capacitor because it is storing the charge. So this is capacity. Yes, capacity C equal to stored charge divided by potential difference. This potential difference is created or developed by this charge only. That means indirectly this numerator charge, that charge is responsible for development of potential difference, indirectly creation of electric field. So responsible charge divided by potential difference. This ratio is nothing but a capacity of a capacitor. Right now, here one isolated conducting sphere I have taken. So isolated conducting sphere of radius r, capacitance is C equal to Q by delta V. That delta V already we know, Q by 4 pi epsilon naught r. After substitution of this delta V in that, we will get 4 pi epsilon naught into r. That means, students, here capacity of a capacitor depends on radius of a conducting sphere, means indirectly geometry of a capacitor, sizes, shapes, that is now area, yes, width, length, these all depending factors. So capacitance of a capacitor depends on geometry of the capacitor, but not on the charge stored in the capacitor. Charge is now cancelled, there is independent. Only geometry, how much area, how much length, how much breadth, how much thickness, these all now geometry related parameters. Capacity depends on geometry of a capacitor, and also the medium, yes, in which our capacitor is placed. Yes, suppose, students, here free space, that's why here permittivity of a free space epsilon naught now came to our equation. Suppose here water is there or some other medium is there, its dielectric constant K also coming to our equation, that is 4 pi K epsilon naught into R. K means dielectric constant, it is not 1 by 4 pi epsilon naught. K is a dielectric constant in our present medium. So this is capacitance of a one isolated conducting sphere, and the conclusion is two conclusions here. Capacitance of a capacitor is the ratio of responsible charge and potential difference between the 2 points. Which 2 points? In between these 2 points only field existed, electric field existed. That is the first conclusion. Second conclusion, capacitance of a capacitor depends on geometry of the capacitor but not on the charge stored, and also the medium where this capacitor is placed. So these two conclusions, students, please take from here to here, then later write notes also. Yes, students, here, for example purpose, one isolated conducting sphere only consider. But with this conducting sphere, no any use. Why no use means electric energy stored in electric field. But here electric field where existed? From surface to infinity existed. That energy, how we utilize, we can't utilize. Any suppose energy there in any one small device, then we can utilize that. But here energy from surface to infinity there, that energy we can't utilize. For example, water inside the tank is there, we can utilize. The same water moving from now one side of road to another side, we can't utilize that. So the same way, here also electric field is from surface to infinity. We can't utilize that energy. So only for understanding of capacitance, only this now example purpose now I kept here. But without utilization of energy, yes, this capacitor no any use. So that's why, students, some utilizable, yes, different forms of capacitors we have, that all capacitors one by one I will explain. So that means capacitor not only just now storage of energy, we need to utilize that energy, otherwise no use. But here in the present example, we can't utilize because energy is now from surface to infinity, this we can't utilize. So next